You know, for the longest time, science had these two neat little boxes. Everything in the universe was either a wave, kind of like a ripple in a pond, or it was a particle, like a tiny grain of sand. Simple, right? But then quantum physics came along and basically just blew all of that up, showing us that at the very bottom of reality, the rules we thought we knew just don't apply.
And really, that's the big, kind of mind-bending question, isn't it? It suggests that this solid, predictable world we think we know, well, it's built on something that's way more uncertain and, has this weird double identity.
Yeah, and this slide, it nails that shift perfectly. See, classical physics was all about either or. Simple. But quantum physics comes along and says, nope, it's way stranger than that. It's both and. Things can actually be in multiple states at the same time. It's a wild idea called superposition, at least until we force them to pick one.
So where do we even start with this? Well, light is the perfect place. It was really the first big clue that our old rules were, well, wrong. And the crazy part is, we see its dual personality at work every single day. We just don't realize it. Okay, so on one side of the coin, light acts just like a wave. Totally predictable. I mean, think about it. You see light bend when it goes through a glass of water, right? Or how a prism splits light into a rainbow. That's all classic, textbook wave stuff that scientists have known about for ages. But then, things got weird. There was this thing called the photoelectric effect. Basically, scientists saw that if you shine light on metal, sometimes it knocks these tiny particles, electrons, right off. But, and this is the kicker, it only worked if the light hit with a specific punch of energy. It was acting less like a gentle wave and more like a tiny, microscopic bullet. And that bullet, that's a particle. We call it a photon. And just like that, light wasn't just a wave anymore.
Okay, and this is where it goes from weird to just, what? So scientists started asking, all right, if light waves can pretend to be particles, what about the other way around? Could a particle act like a wave? The answer came from the most famous experiment in all of physics.
This is it, the double-slit experiment. It's so simple in its design, but the results are just profound. The whole point was to basically corner matter itself and ask it straight up, what are you, a wave or a particle? Pick one.
So here's the setup. You take electrons, and we've always thought of these as tiny, solid particles, right? And you shoot them one by one at a wall with two little slits in it. Now, if they're just little baseballs, you'd expect to see two lines on the detector wall behind the slits. Makes sense. But that is not what happens. Not even close. Instead, you get this interference pattern, a pattern that only a wave could make. It's as if each individual electron somehow went through both slits at the exact same time and interfered with itself. How is that even possible?
This was so bizarre, so completely against all common sense that physicists just had to look. They thought, okay, we're going to peek. So they set up a tiny little detector right at the slits, just to actually watch which slit the electron goes through. And this is where reality just seems to break. Get this. The second you start watching, the instant you measure which slit the electron goes through, the wave pattern completely vanishes. Poof! Gone. And now they act like good little particles, leaving just two simple lines on the detector, exactly like we thought they should in the first place. It's like the act of looking at them forces them to stop messing around and pick a side.
I mean, just let that sink in for a second. The universe literally behaves differently depending on whether or not we're looking at it. And this isn't some philosophical thought experiment. This is a real, repeatable result. It tells us that the observer isn't just a spectator. You're actually part of the experiment. You change the outcome.
Okay, so right now you're probably thinking, this is all super weird, but what does it have to do with me? Well, it turns out this quantum weirdness is the absolute foundation of our modern world. We didn't just discover it, we figured out how to harness it. Seriously, your phone, your computer, lasers, the semiconductors inside pretty much everything, all of it works because we learned how to control whether electrons are acting like waves or acting like particles. Our entire digital age is built on this strange dual-natured reality.
So, what's the big takeaway here? It's that at the deepest, most fundamental level, reality isn't black and white. It's not this or that. It's a whole cloud of possibilities. Nature is totally cool with being both a wave and a particle at the same time. It doesn't have to choose until it's forced to.
And that just leaves us with this one last kind of spooky thought to chew on. If our technology is built on this principle, and the experiment proves that just looking at something changes what it is, then you just have to ask, what does the universe really look like when nobody's watching?